Okay, friends, we're going to continue looking at trig functions. I think we're on lesson 4 or 5. Lesson 5. We are going to look at the period of sinusoidal curves, and great questions to look at would be on pages 33 to 37 in your Math Beacon guidebooks. And great questions to look at within there would be these bolded questions. And of course, the Go Formative is your essential place to let me know how you are doing. So please do those questions. And here we go. So period of sinusoidal curves. So here is, we're going to break the period into two different parts. And so here's what we've looked at so far. We've looked at radians, we've looked at terminology, we've looked at trig ratios, and last lesson we looked at vertical displacement, amplitude, and phase shift. And today we're going to look at part 1 of the period of a function. So let's look more closely at that. Okay. So these are the things I'd like you to be comfortable with today, being able to create equations of functions with different functions. This is an interesting video for you to look at. If you're interested, please find that in the slide deck. Click play there, and you will learn a little bit more about the difference that frequency makes to the visible light we see. So, two things. By the end of this class, you should know what a periodic function is, and that is a function that returns to the same value at regular intervals, and the period of a function is how long it takes to complete one cycle or for the function to return to the same value. So let's take a look at these. My first question is, what is the length of the period of these? So please pause the video, answer these questions, and we will go over it in just a moment. Okay, the red one, that is 2 pi. We can see 2 pi down here, and we can see that there's the same spot, and it returns to that spot. We can see that that is a period of 2 pi. Let's look at this green one. Well, the green one looks much longer. That looks to me like it's 6 pi, and it is. Let's look at the red guy. Well, this one looks like half of 2 pi, so that looks like pi, and this one looks really small, so in between 1, 2, 3, 4. This looks like it would be pi over 2, of course, because that's 2 pi, and that would be pi, and that would be pi over 2. So the question today is, how can we impact the period? And so that's what we're going to look at. So what I'd like you to do on the same grid is graph each of these. And basically what we have here is, if we know from our first chapter that when you replace x with 2x, you end up that's a horizontal compression by a factor of 1/2. So this value here, the 2, cuts the period from 2 pi into so the blue one represents the original function, and if we cut it in half, then the period would be pi. So notice that the sine wave's shape still exists. It starts at an average, it goes up, it comes down, and finishes at an average. I think if we click this, it's going to take us to something that it didn't take us to. So I don't know what that's about. Now we're going to look at the cosine wave. If we replace x with 0.5x, well, that's going to make it twice as long. So notice right here in blue, we have the original function. And is that taking us to a graph? That is perfect. So I'm not sure where I was going with this, but it sure looks like a... I'm just going to leave that. I'm not sure what I wanted you to see there. But anyway, here's our function at 2 pi. We now know that this period would be not 2 pi, but 4 pi. So here's 4 pi. Notice that the cosine wave starting at a max, ending at a max. Halfway in between is at a minimum. And you can see that we're starting high, at low, and coming back up. So once again, we're going to be stretching these with horizontal stretches. So what is the period of sine bx? This is an important observation. If I were you, I would put this on your front of your notes, that the period of a sine and cosine wave is 2 pi divided by b. Notice up here, if we take that b value and divide 2 pi by 2, we get a period of we get a period of pi. And if we divide 2 pi by 0.5, you're going to get a period of 4 pi. So that's an important observation. So let's take it to the next level. Determine the period of each of the following verbally as needed. What would be the period of this? Pause this video and answer these questions. All right, this first one, there's the b value. So it's going to be 2 pi divided by b. The b value in this question is 5, so that'll be 2 pi divided by 5. And the b value here is 1/7, so that's going to be 2 pi divided by 1/7. And when you rearrange that, you're going to get your 14 pi, and right here, 2 pi divided by 3/5. And if you do the math on that, you're going to get 10 pi over 3. So there you go. I hope that was helpful. Please send us a note if you are unsure as to what that means. Now, write the equation with the following period. Do as many of these as you need to. So a sine wave with a period of 8 pi. Okay, so this one would be sine. Oh, I didn't really provide much support on that. Okay, so what you want to do here is remember our formula is 2 pi divided by b equals the period. So 8 pi must equal 2 pi over b, and just rearrange that to get the b value. Okay, so there you go. Again here, what you do is you take the period equals 2 pi divided by b. So if pi over 8 equals 2 pi over b, rearrange that. And here are the answers. Okay, so once again, this requires you to take the period. The formula is 2 pi divided by b, and so if 3 pi over 7 equals 2 pi over b, rearrange those fractions, isolate b, and you'll get your b value here. Alrighty, so now what we're going to do is create an equation of following sinusoidal functions, and this could represent a sine or a cosine wave. We're going to take a look at this graph right here and write a sine wave for it. So the first thing we want to do is take a look at what the vertical displacement is in my mind. The vertical displacement is 2. It's the average. So there's going to be a +2 here, and the amplitude looks like a half. So we're going to have a half sine da-da-da. Okay, this is a sine wave. And so a sine wave usually starts at an average, and if it's going up, notice that we could phase shift to here, or to that point, or to that point. I'm going to phase shift to this point right here. So notice that the average, it should be right there, but it's over there. So I can see that this point here, this average has been shifted over, and it's been shifted from there, pi over 6. And that's why we have a pi over 6 here. Another thing we might want to look at is what the length of the period is. And so from this point to this point is pi over 3. And so what we'd want to do here to calculate this b value is go 2 pi divided by b equals pi over 3 and isolate for b. And that's where you get that 6 from. Okay, let's look at a cosine wave. Notice that the vertical displacement will be the same. Notice that the amplitude will be the same and the b value will be the same. The only thing that's different is the pi over 12 piece, and that might be a bit challenging for you to see or to make sense of, but here we go. So we know that a negative cosine wave starts at a minimum. So the minimum is right there. So it's been shifted from here to here. So it's got to be an x minus something. But what? Well, if I can see that this is pi over 6 to here, that looks like it's halfway in between 0 and pi over 6. So I'm just going to go ahead and divide pi over 6 by 2. And when I do that, I'm going to get the pi over 12. Once again, if you're not sure where this 6 comes from, I can see that the period here, the period length, is pi over 3. So I'm going to say pi over 3. Let's see if I can do this with a pen. I'm going to go, so pi over 3 has to equal 2 pi over b. So then what I'm going to do is I'm going to rearrange all that and isolate for b. So that when I do that, I'm going to end up getting that b is equal to 2 pi times 3 over 3. So basically, those are going to cancel out, and there I made a silly mistake somehow. The period is pi over 3. Oh, that's because, oh my gosh, I didn't make any mistakes. I'm just having trouble reading my own writing. That is, oh my goodness, that's embarrassing. Hey, you saw it here first. I'm gonna learn from my mistakes here. let's be neater, excuse me. The period is 2 pi divided by b, and the period is pi over 3. I see how I got confused. So that's going to be the 3 times 2 pi is going to be 6 pi on the top, equals pi b. We can clearly see then that b must equal 6. Excuse that clear, silly mistake. Okay, so we're going to continue here. We'll give it a little bit more practice with these graphs. I'm going to do a negative sine wave here, so pause the video and write your own equation first. Okay, so let's take a peek here. So I'm going to show you the equation, but here's the thing. I can see that the thing that's in the middle here, the line that's in the middle, is the -5. Okay, so I can see if I count it up, I can count up 6 from 5, -5, and if I count 6 down, I get my vertical displacement at -5 and my amplitude of 6. Now, if it needs to be a negative sine wave, that means I need to look for the average and then it has to go down. So I can see right there that it's moving down, and that is pi over 3, and that's why this says theta pi minus 3. Okay? What I also may want to figure out here is the period. And the period right here, there's my b value. And so the period of this guy here looks like it went from 0 to 2 pi over 3. So once again, what I'm going to do is I'm going to get my period of 2 pi over 3, excuse me, equals 2 pi over b. Now we're lucky enough on this one that we don't need to rearrange. Since the numerators are both 2 pi, then this b value here has to be 3. I can see that. So there we go. Alrighty, so now let's look at this next guy. And you'll notice here that the vertical displacement is the same, the b value is the same, and the amplitude is the same. A positive cosine, so I'm going to look for that point. Oops. I'm going to look for that point, or that point. I could phase shift to any of them. So what I'm going to do is just phase shift to this one. Notice the cosine wave should be there at a maximum, but it's not. So it's been shifted over pi over 6. And that's why that value there is pi over 6. So the phase shift is pi over 6. The amplitude is 6. The period was 2 pi over 3, and the vertical displacement was -5. So if we were to graph this, let's see if we can graph this together. And I'll try my best to help you make sense of it. So I'm going to attempt to show you my thinking here, and I'm going to start off like this. I know that the vertical displacement is +3. So if I go up 3, I'm going to go 1. I'm going to put a dotted line there. And remember, we all said that +3 doesn't change the shape of the graph. Also, we know that the phase shift doesn't change the shape of the graph as well. So I'm going to call that pi over 2 right there. And I'm going to call this pi. So if I do that, then I'm going to put little hash marks there and there. So that would mean that this length here is pi over 6. And that's often a good one to go with. But I'm going to go pi. I'm going to call this 3 pi over 2. And I'm going to call this 2 pi. And I'll go a little bit further into this next bit. So this would be 5 pi over 2. 5 pi, that's a terrible, terrible, terrible looking pi. I don't know if I can erase that. I can't. So that's a pi right there. Okay, so now let's do a quick sketch of this thing. So we know that the phase shift is to there. So basically, from this point here, from this point right here, all I have to do is sketch a basic cosine wave. Well, I know a cosine wave usually starts, the period is usually 2 pi. So that would mean I'd go from pi all the way all over to there. But because of this b value, because that b value is 1/2, we know that that is going to make this thing much longer, isn't it? I haven't done a very good job of this at all. So basically the period here is going to be 4 pi. So that means I have done a horrendous job of drawing this, not paid attention well at all. So I'm going to try to clean this up, but it's going to be ugly. In fact, I'm going to start this again, and that's all there is to it. It was too bad. There's no returning. I'm going to try that again. So here's my line. Here is my vertical displacement. We call that vertical displacement y equals 3. Okay, then what I'm going to do is I'm going to get my phase shift. My phase shift is going to be pi over 2. Okay, and then what I'm going to do is I know that the period is going to be 4 pi. So I'm going to basically draw a cosine wave, and I'll tell you what I mean by that in a sec. So the period is 4 pi. So I know that a cosine wave usually starts at a maximum, but because of the -2, it's going to reflect down, and it's going to start at a minimum. So I know it's going to start at a minimum and end at a minimum, and that means that it's going to look something like that, where this distance from here to there is 4 pi. So I know that. Okay, so that's what its general shape would look like. Now, I've not done a great job because I don't have the grid on this that I would like, but keep in mind that that's 4 pi, so that this distance right here would have to be, if I do the math on it, it's got to be, that's going to be 9 pi over 2 right there. Okay, so this is not a great drawing by any stretch. I'm so thankful that I have Desmos that I can help do a neater graph for us. Okay, so here we go. Notice that the vertical displacement is 3, so it pops the whole thing up 3, and the phase shift is pi over 2. So from that point there, all we have to do is just graph this guy here, because remember, the pi over 2 and the 3 don't change the shape of the graph. The next thing I would think about is, here's my starting point, and the gap from here to here has to be 4 pi, and when you look at it, it is 4 pi. Okay, so once you know that starting point and that starting point, halfway in between the minimums, we're going to be at a maximum, and once you know that point, it's easy to find that average. Now, my drawing before was really hard to follow for a number of reasons, but one of them was we didn't have a clear grid on that. That would have been better if I had had that. So despite that surprising explanation, I hope that in the end you stayed with it and followed. Okay, so we're going to end right there. Please fill out this form. If you're having any trouble, contact us.